Hi, let's now take a look at this homework problem. And in this homework problem, we need to find the volume of the solid generated by this region, the region bounded by these two functions. And this region is going to be revolved about x-axis. Hi, this is Dr. Huan. Now let's take a look at this homework problem. We need to find the volume of the solid generated when the region bounded by these two functions is revolved about the x-axis. And the graph of this function is given here. In order for us to determine the correct method, now let's take a look at this problem. We need to use the washer method to find the volume of the solid generated when the region bounded by these two functions is revolved about the x-axis. The first part of the question is we need to determine dy or dx. Keep in mind we need to use washer method. So let's zoom into this graph. And how about we try both? Let's first try the dy, integrate with respect to dy. That means we need to draw a Riemann integral horizontally so that we create a slice that has the width delta y, right? That's how we get the dy. And rotate this slice about x-axis to see if it will create a washer or not. If it creates a washer, you're on the right track because the question is asking us to use washer method. So let's try. Well, obviously, if you rotate this slice, it's not going to be a washer. It's more of a cylindrical shell, right? So this is what we would expect if this horizontal slice is rotated about x-axis. So that means we should rule out the delta y, the dy. So we cannot do that one. We have to do the dx. Let's zoom in again, just to make sure that you agree that we should do the dx. Dx means you gotta revolve slice x vertically. And if you slice vertically, then when this slice is revolved about x-axis, then you're gonna get a washer. So we are on the right track. Now time to set up this integral. And when we set up the integral, the integrand will be pi of the outer radius of the washer square, right? So outer square minus the inner radius of the washer square, so inner square dx, so that you get the cross-sectional area. To determine the limit, the lower limit is 0. It's easy to see for this problem because when you set these two equal, 0 is clearly a solution. And to find the upper limit, let's do a quick algebra. 9 square root of x equals 3x. Maybe we can cancel the 3 so that this is left. We're left with 3 here. And square both sides. We have 9x on the left equals x squared on the right. And solve this equation. It gives us x equals 9. You can see that by canceling x at the same time on both sides. So this is the integral that we have, right? And now let's type that in. So this is from 0 to 9. And this will be pi times the outer square, right? Outer, if you look at the graph, the outer is 9 square root of x square minus the inner one is the function on the bottom, which is 3x square. Let's check that. And now we can just go ahead and evaluate this one. This is pi can be moved out because it's constant. And 9 square root of quantity 9 square root of x square is going to be 81x. And quantity 3x squared is 9x squared dx. And then, so let's find the antiderivative. The first one is 81 over 2x squared. The second one will be 3x cubed. And let's evaluate at these two values. And after the algebra is 2187 pi over 2. So let's type that in. 2187 pi over 2. Okay, so this is it for this question.